welcome to today's lesson on measures of position. In this lesson, we will tackle one of the measures of position, which is the quartile. As a recall of our previous lesson, to how many parts do quartile values divide a distribution? Very good. 4 parts. All right. So for today's lesson, the following are our objectives. Number 1, calculate the specified measure of position for ungrouped data, specifically quartiles. Then, perform the given task with accuracy. By the way, when we talk about ungrouped data, here, our scores or values in our dataset are not classified using any grouping scheme, meaning whatever values or scores we gather, we list it, and that's the data that we will process. Okay? So, are you now ready? Let's start learning. Again, quartiles are the points that divide the ranked data into 4 equal parts. So each set of data has 3 quartiles. We have quartile 1, quartile 2, and quartile 3. So since quartile values divide our distribution into 4 equal parts, each division in here corresponds to 25% of our data set. Okay, so when we speak of ranked data in here, it means that our values in the data set are arranged in either increasing or decreasing order. But for us to easily determine our quartile values, we usually arrange our values in the data set in increasing order, or from least to greatest. For example, in the exam, we want to know your performance with respect to the other test takers. So we use the concept of the measures of position. If your score falls on quartile 1, it means that 25% of the test takers scored below your score, and the remaining 75% of the test takers scored above your score. Let's say this time, your score falls on the second quartile. If your score falls on the second quartile, it means that 50% of the test takers scored below your score, the yellow one, and the remaining 50% of the test takers, the blue one, scored above your score. In other words, you are at the middle of the test takers of that particular exam. And finally, if your score falls on quartile 3, it means that 75% of the test takers scored below your score, the yellow one. And the remaining 25%, the blue one, of the test takers scored above your score. Note that the higher the corresponding quartile value of your score, the better you perform on a particular test or exam. So, how do we find for the unknown quartile value? How do we determine these values which divide our distribution into 4 equal parts? So we have here the steps. So to find for the unknown quartile values, we follow the steps. Number 1, we arrange the values in ascending order, or from least to greatest. Then we locate the position of scores in our distribution using this formula. That's it. Okay, so quartile, or Q sub k is equal to k times the quantity n plus 1 over 4. Now, if our answer in step 2 is a whole number, we don't need to proceed to step 3. But if our answer in step 2, after using this formula, is a decimal number, we have to proceed to step 3. And step 3 is interpolation. This will be explained further. We have an example later. Okay, so the formula flashed here on screen is used to determine the position. Take note, the position of the unknown quartile value. So Q sub k is equal to k times n plus 1 over 4. So whatever answer we get using this formula, this indicates the position of the unknown quartile value. Q sub k represents our quartile. Our k is our quartile location. And finally, n is the number of elements in our dataset. Let's say, for example, our answer is 2. After we use this formula, the result is 2. It means that our quartile value, okay, is located in the second position. Not that our quartile value is equal to 2. Okay? This time, let's have an example. So given the following values, 8, 2, 5, 4, 8, 5, 7, 1, 3, 6, and 9. We have to find for the quartile 1 value, quartile 2 value, quartile 3 value, and we have to interpret the scores. We have to interpret the results that we got. Okay? First, let's find for the quartile 1 value. So again, let's recap the steps. First, we have to arrange the values in ascending order. Second, we locate the position of our score in this distribution using the formula. If our answer in the formula is a whole number, no need to proceed to step 3. But if our answer after using the formula is a decimal number, we have to proceed to step 3, which is interpolation. Okay, so first, we have to arrange the values in increasing order. So we have here the arranged values. Our lowest score is 1, and our highest score is 9. Second step is to locate the position of quartile 1 value in the distribution. This time, we'll now be using the formula. Okay, so our formula is Q sub k is equal to k times the quantity n plus 1 over 4. So we are looking for quartile 1 value. That's why we have here Q sub 1. Our k is equal to 1, okay, because we base it here. Q sub 1 is in the form Q sub k. We have Q and Q. K is therefore equal to 1. That's why we have here k is equal to 1. So if we are looking for quartile 1, k is equal to 1. If we are looking for quartile 2, k is equal to 2. If we are looking for quartile 3, k is equal to 3. Okay? And our n in here is 11 because we have 11 scores in our dates. Okay? Let's now substitute the given to our formula. So, take note that our formula only gives us the position of our quartile 1 value. So, position of quartile 1 is equal to 1. Our k here is equal to 1. Okay, we are following this form. K is replaced by 1 times the quantity, n is replaced by 11. And here is replaced by 11. Plus 1, copy the rest of the formula over 4. Plus 1 over 4. Then perform the operation. So we have 11 plus 1, that gives us 12. 12 times 1, that gives us 12 still. Then we copy, divided by 4. 12 divided by 4 gives us 3. So meaning, the quartile 1 value is located in the third position. Not that the quartile 1 value is equal to 3. Okay? It's only the position. So Q1 value is located in the third position. So since our answer in the formula is a whole number, which is 3, We don't need to proceed to step 3, which is interpolation. Thus, we say that our quartile 1 value is located in the 3rd position. Now, we go back to our arranged values and locate the value of quartile 1. So, based on our arranged values, 3rd position is here. From the lowest, it's 4. So, okay, 3rd position. So, therefore, our Q1 value is equal to 3. Okay, Q1 value is equal to 3. Okay, next, let's find for the quartile 2 value. First, we arrange the values. So we have 1, 2, 3, 4, 5, 5, 6, 7, 8, 8, and 9. Step 2, we use the formula to locate the position of quartile 2 value in our distribution. Okay, so this is our formula. We're looking for quartile 2, so that's why we have here Q sub 2. And for our given, again, we're looking for quartile 2, therefore K is equal to 2, and N is still 11 because we still have 11 values in our data set. Okay, let's now substitute the given to our formula. Okay, so position of quartile 2 is equal to K is replaced by 2 times the quantity, N is replaced by 11, and then copy the rest of the formula, plus 1 over 4, plus 1 over 4. We perform the operation. So 11 plus 1 is equal to 12 times 2. That gives us 24 divided by 4. So 24 divided by 4, that gives us 6. So meaning quartile 2 value is located in the 6th position. So since our answer after using our formula is a whole number, which is 6, we don't need to proceed to step 3, which is interpolation. Now we locate the quartile 2 value. Okay. Based on our arranged values, the 6th position is here. Okay. That's it. So our quartile 2 value then is equal to 5. Okay, that's the value in the 6th position. Okay, the value that corresponds to the 6th position. Next, let's move to our 3rd task. Let's find for the Q3 value. So step 1, again, we have to arrange the values up here. Locate the position of quartile 3 value in our distribution. So we again use the formula. We are looking for Q sub 3. So therefore, our K is equal to 3 and still N is 11 because we're dealing with the same data set. Okay, and there are 11 values in our data set. We now substitute the given to our formula. So we have position of quartile 3 is equal to 3, we replace K by 3, times the quantity 11, we replace N by 11. And so we have here, and then we copy the rest of the formula, plus 1 over 4, plus 1 over 4. We perform the operation. So we have 36 divided by 4, that gives us 9. So Q3 value is located in the 9th position. So since our answer after using the formula is a whole number, we don't need to proceed to step 3, which is interpolation. Now, we locate the value that corresponds to the 9th position based on our arranged values. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the value in the 9th position. Therefore, our Q3 value is equal to 8. Okay. Now let's proceed to the interpretation of results. Based on our answers, the following are our quartile values, 3, 5, and 8. So since a score of 3 falls on quartile 1, it means that, okay, 25% of the values are less than or equal to 3, and the remaining 75% are greater than or equal to 3. Okay? Next, for our quartile 2 value, which is equal to 5, it means that the score of 5, which falls on quartile 2, means that 50% of the values in our data set is less than or equal to 5. And the remaining 50% are greater than or equal to 5. Okay? Finally, a score of 8 falls on quartile 3. It means that 75% of the values here are less than or equal to 8. And the remaining 25% are greater than or equal to 8. Okay, that's all for example number 1. Let's now proceed to example number 2. So given we have the following values 1, 3, 7, 7, 16, 21, 27, 30, and 31. We have to find for the quartile 2 value and we have to interpret our result. Okay, so first let's find quartile 2 value. So for our step 1, we have to arrange the values. So we have 1, 3, no problem because the values are now arranged. So we simply copy 1, 3, 7, 7, 16, 21, 27, 30, and 31. Next step, we use the formula for quartiles to locate the position of quartile 2 value. So we have Q sub k is equal to k times the quantity n plus 1 over 4. We are looking for quartile 2. That's why we have here Q sub 2. And our k value is equal to 2. As you notice, n is equal to 9 because there are 9 values in our data set. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's now substitute the given to our formula. So, position of quartile 2 is equal to, we replace k by 2. Okay, we have here 2. And then we replace n by 9. That's why we have here 9. Then copy the rest of the formula. Plus 1 over 4. Plus 1 over 4. So perform the operation. We have 9 plus 1. That gives us 10 times 2. 20 over 4. Okay, that's why we have here 20 over 4. Then 20 divided by 4. That gives us 5. So Q2 value is located in the 5th position. Okay. Going back to our arranged values in step 1. So 5th position is here. 1, 2, 3, 4, 5. There's 1. So this is our Q2 value. Therefore, Q2 is equal to 16. For our interpretation of result, if a score 16 falls on Q2, it means that 50% of the values in our data set are less than or equal to 16. And the remaining 50% are greater than or equal to 16. Okay? Let's have another example. Let's say our data set is composed of the following values 2, 3, 7, 7, 16, 24, 27, 30, and 35. You have to find, or we have to find for quartile 1 value, quartile 3 value, and you have to interpret our result. Okay. So let's first find for the quartile 1 value. So step 1, of course, we have to arrange the values. Okay, so we are lucky because our values are now arranged. So we simply copy. So we have 2, 3, 7, 7, 16, 24, 27, 30, and 35. Next step is we use the formula for quartiles to locate the position of quartile 1 value. So we have here, this is our formula. We are looking for quartile 1. That's why we have here q sub 1. And of course, we have here k is equal to 1. And n is equal to 9 because there are 9 values in our data set. 1, 2, 3, 4, 5, 6, 7, 8. All right. Let's now substitute the given to our formula. So position of quartile 1 is equal to k is 1. Okay, we replace k by 1. So you have here 1. We replace n by 9. So you have here 9. And then copy the rest of the formula. Plus 1 over 4. Plus 1 over 4. Now let's perform the operation. 9 plus 1, 10. Times 1, still 10. Divided by 4. Okay, so 10 divided by 4. That gives us 2.5. So Q1 value is located in the 2.5 position. So as you can see in here, our answer in step 2 is a decimal number. And I've made mention that if our answer in step 2 is a decimal number, we have to proceed to step 3, which is interpolation. Okay? So for the interpolation process, this is how we do it. Okay, since our answer again in step 2 is a decimal number, 2.5 position, we use the interpolation process. So to perform the interpolation process, we first locate the 2.5 position based on our arranged values in step 1. Okay. So 2.5 position is between the second score and the third score. Okay. So the 2.5 position is between the second and the third positions. Correct. It's the other way of saying it. So our score in the second position is 3. Okay. And our score in the third position is 7. Okay. So to find the score corresponding to 2.5 position, we have to add the second score plus the 0.5 score. Again, we have to add the second score and the 0.5 score. So to find for the quartile 1 value, we have here 3 plus 0.5 times the quantity 7 minus 3. Okay, so 3 here corresponds to our second score, and the 0.5 times the quantity 7 minus 3 corresponds to our 0.5 score. If we add the second score and the 0.5 score, that will give us the 2.5 score, which corresponds to the 2.5 position. Okay, so where did we get 0.5 for the 0.5 score? We get it from our decimal part of our answer in step 2. Our answer in step 2 is 2.5. So to get the 0.5 score, we get the decimal part of it. So 0.5 and 7 corresponds to our third score, and 3 corresponds to our second score. Okay, so if we have this expression, that will give us the 0.5 score. So second score again plus 0.5 score, we get 2.5 score, which corresponds to the 2.5 position. We perform the process that will give us copy 3 plus 7 minus 3 is 4, and 4 times 0.5, that gives us 2. So 3 plus 2 is 5. So our Q1 value then is equal to 5. Okay, now let's find for the Q3 value. So first, we have to arrange the values. So we use the same data set. Next, we locate the position of Q3 value in our distribution. We will be using the formula. So we are looking for quartile 3 value. That's why we have here Q3 for our find. And for our given, K will then be equal to 3 and N is equal to 9. For we have 9 values in our data set. Now we substitute the given to our formula. We have position of quartile 3 is equal to, we replace K by 3, Okay, we replace n by 9. Okay, so we copy the rest of the formula. Plus 1 over 4. We perform the operation. 9 plus 1 is 10 times 3. That gives us 30 divided by 4. So 30 divided by 4, that gives us 7.5. Q3 value is located in the 7.5th position. Okay, so since our answer after using the formula is a decimal number, 7.5, we have to proceed to step 3, which is interpolation. Okay, so we locate, to perform the interpolation process, we first locate the 7.5th position. And we know that it is between the 7th and the 8th position. Okay, 1, 2, 3, 4, 5, 6, 7. This is the score that corresponds to the 7th position, 27. And this is the score that corresponds to the 8th position, 30. Okay, so we have to get the 7.5th score, which corresponds to the 7.5th position, to find the value of Q3. So Q3 value then is equal to, okay, 27 plus 0.5 times the quantity 30 minus 27. 27 again is our 7th score. 0.5 here comes from the decimal part of our answer in step 2. Okay, 0.5 times the quantity 30, this is our 8th score, minus 27, which is our 7th score. This expression gives us this part, the 0.5 score. So if we add the 7th score and the 0.5 score, that will give us 7.5 score, which corresponds to the 7.5 position. So we perform the process. 27 plus 30 minus 27 is 3 times 0.5, that gives us 1.5. So we add the numbers, we get the Q3 value, which is 28.5. So for our interpretation of results, again, Q1 value is located in the 2.5th position, and that is equal to 5. This means that Q1 value, which is 5, means that 25% of the values are less than or equal to 5. And the remaining 75% are greater than or equal to 5. 25% of the values are less than or equal to 5, and the remaining 75% of the values are greater than or equal to 5. Next, for the Q3 value, it's located in the 7.5th position here. Okay. And it is equal to 28.5. So a Q3 value, which is 28.5, means that 75% here of the values are less than or equal to 28.5, and the remaining 25% are greater than or equal to 28.5. All right, so we are done with quartiles. So to recap what we have just discussed, quartiles are again the points that divide the rank data into 4 equal points. So in each data set, we have 3 quartile values. So we have here the steps in finding for the unknown quartile values. 1, arrange the values in ascending order, or from least to greatest. 2, locate the position of scores in the distribution using the formula on the left. And if our answer in step 2 is a whole number, no need to proceed to step 3. But if our answer in step 2, after using this formula, is a decimal number, we proceed to step 3, which is interpolation. Finally, our session for today has come to an end. Thank you for listening and see you next time. Bye!